Good morning. Welcome to my channel. Today's topic is a data structure. It's a chapter number 8, data structure 1 using the list. So, very first question what comes in our mind is, what do you mean by data structure? So, data structures are a way of storing and organizing the data efficiently. What do you mean by this? When I want to store any value in a data structure, so data structure is nothing, it is one storage area. We have a various type of data structures in our Python program. So we will discuss later on. So how we store the value. So that is basically the data structure, how we insert the value, how we delete, how we can insert, delete, sort, merge. So these are the various operations which we will apply on the data structure. So what it demands, it's basically allowed to easily assess and perform operations on the data. Data is nothing. It is a set of the values, or we can say it is a raw data. What is the raw data? Raw data is a data which we fed into the computer. And after the processing only, it becomes a useful or a meaningful data. So raw data changes into the meaningful data after the processing only. So after the processing, we just convert it into the raw data to the meaningful information. So after that, the data structure now classified into the following two types. What are the two types? The very first type is the simple data structure. Well, now the question comes, what is the simple data structure? So simple data structures are nothing. It builds from the primitive data type. So the question comes, what is the primitive data type? The primitive data type is that which is the basic data type, like integers, float, characters, string. So all these are the basic data types of the Python. So whatever the data structure which made from the basic data types, that are known as a simple data structures. So the examples are arrays. And the second one is a compound data structure. So compound data structure is what? It can be a combined in various way to just make a complex structure. So whenever we have two data structures and we combine together, and obviously if the two already data structures are there and we combine together to make a new data structure, so obviously that will become a complex one. So linked list, stacks, queues, so these are all there which are making here a complex data structure. So this is a full diagram of the data structure. So listen very carefully. So this is a data structure. Data structures are of two types, primitive and non-primitive. So primitive is what which is made from the basic data types like integer, float, character, string. So basic one. Non-primitive are of two types, linear and non-linear. So the question comes, what do you mean by linear? So linear are those one which have only one level, like array. Array store the data into the consecutive memory locations. So it is of one level only. But in the non-linear, we have a many levels. So when we just discuss these three, at that time you will be a more clear what are the different levels. So right now you just listen very carefully. Linear is a what which is at one level. Non-linears are that which are at the different level. Like we have a hierarchies, different hierarchies. Like we have a parents, and after that we are there, means grandparents, parents, children. So we have a different hierarchy. So that comes under the non-linear. Now in the linear, we have a two thing, static and dynamic. So what is static? Static is that whose values are fixed. We cannot change at the moment of the time. But in the dynamic, what is there? In the dynamic, we can change according to the time. So when we use the like data randomly, so at the time we can change that also. But here in the static, it is fixed, we cannot change. example is array. Like in an array, it is in the form of consecutive memory location. If A0 is a 4, so it is 4 only. We cannot change according to the time. Now in the dynamic, we have a three things like linked list, tags, and queue. So one by one, we will discuss later on the slides. And in the nonlinear, we have again two type trees and graph. So in that, what we does, this is a again a parent hierarchy one. So in that, we just come into the parent level. So this is all about this diagram. Next is the array. So what do you mean by array? Arrays are the one which takes the consecutive memory location. Consecutive memory location means what? First value is at 0. Second is at 1, 2 means one by one it will store there. Consecutive means a neighboring element. So for this is the first index. We can say this element is at 8 index. This whole is known as indices. Indices means the whole thing. So if I want to check what is the value at the index 4, so I just check at A4 here. So here only the value is at A4. So now this total length is what? 10. Why? Because it starts with the 0. So obviously 0th element is also added together. So the total index of the array is a 10 only. After that, stacks and queues. So what do you mean by stacks and queue? Firstly, stack is one which works on last in, first out. So what is this? If I make a pile of the books, so obviously I just insert the book, means I put the book at the top of the books only. And if I want to take any book, so firstly I just take the top level book, and then second, and then so on. Same like that, these are the books. If I want to push it, so obviously I just put here, and if I want to remove it, I just remove from here. So at the same point, means at the top only there is a insertion and there is a deletion also. This is the top, so it will work on the last in, first out. So whatever the thing comes at the last, it will remove firstly. So insertion and deletion happen on the same end. So this is the same end, which is the same end on where these deletion or insertion is taken place. So that is the top one only. After that, there is a queue. So queue is what? It is like a queue. Suppose I want to take a ticket from the ticket counter. So obviously the person who comes first takes the ticket firstly. So same like that, there are the two things. This one and this is one gate and this is one gate. Obviously this, suppose this is a one person who wants to take the ticket and here is the ticket counter. So obviously whenever this person take the ticket and he will come out. So it works on first in, first out. Who enters the queue firstly? So obviously he will get the ticket firstly. So that is a first in, first out. But just see here, if I am in a queue, so obviously if any person wants to take a ticket, so he will be at the end of the queue. It means is insertion at the one end and deletion at the one end. Deletion means if I take the ticket, obviously I just go out of the queue from the another end. So whatever the end is used for the deletion to move out, that is known as a front. And the end where the insertion is being taken place means the persons are standing here in the queue for taking the ticket. So that end is known as a rear. For insertion, we will use NQ, and for the deletion, we use the DQ. So this topic is in the next chapter, the full topic stacks and queues using linked list in the chapter number 9. So that we'll discuss in the another video when we just start with the chapter number 9. After that, we have a linked list. So linked lists are what? It are of two types, singly linked list and doubly linked list. So what is this? So this is basically one node. This is one node. It means it consists of two things. One, this is the info, and this is the address part. Address part is what? This address is consist of this one. Means it contains the address of the next node. Name itself signify it is a linked list. Means two nodes are linked together. So of first is what? This is the address of the starting node. Here the address of the next node. Here is the address of next node, and last is null. Null means because there is a no next node. So obviously this address is null, and these all are the info parts. This is a singly linked list. In a doubly linked list, we have a name itself signified doubly. It means we have both the addresses of the previous node as well as the next node. So this consists of three parts: info part, previous address, and next address. So here this is the info. So previous there is a no node. So this is a obviously null. This is the starting address. So here it is the next address of this node. This is the previous. So what is the previous? So address of this node. And here is the next. Next is the address of this node. And previous is the next of next node. This is a doubly, means arrow goes to the different. CURR means currently we are here. We are at this node. Same in this case also. Here it is also a null. Null means they are connected to the last node. Last means it contains the address of the last node only. Next is the trees. Now trees, I already told you, this have a many levels. So levels are what? First is the root node. Root node means the node which have the parental, means this is the one root. If I talk about the tree have a root and it has many stems across that. So same like that, this 8 number is a root node. And then there are again the two numbers here, 3 and 10. So this is a, these two are the childs of this 8 number. Obviously these are the child of this one, but this treat as a parent for these two leaves. This can be treated as a child node or leaf. So name, sometimes we said it to be a leaf, and sometimes it is treated as a child leaf. So no, don't worry, the name is different, the thing is same. So obviously for this it has to be a parent, but for this it has to be a child. So it depends upon the situation whether it is to be treated as a parent or a child. So this is a hierarchy level. Next, we have a various data structure operations. So what are the various data structure operations? It means we put a different finite number of operations. It is defined as a linear sequence of finite number of objects of same type with a following set of operations. So these are the various operations. Very first is insertion. So we can add the number of elements in the data structure. For the deletion, we add number of elements from the data structure also. Searching, we can search the particular value also. Traversing, we process all the elements, means we just move on the all the elements, and whatever the element we want to search, we can easily search it. Sorting, now sorting means we sort the element either in increasing order or decreasing, means ascending or descending order. Merging means, what do you mean? We can combine the two similar data types to form a new structure of the same type. So we have a two structure. If we have a two structure data structure, and if I want to combine them, so we can easily combine them. So these all are the data structures operation which we can easily applied on any data structure. So thank you. These all things are regarding our for eighth chapter, that is data structure. And in the next video, we'll start with a next topic, data structure 2. So if you want to see the next video, please subscribe my channel and like the video.